reciprocal system of vectors. Not a very hot concept, but yes, sometimes question may come on this. But normally when JEE will give you a question on reciprocal system of vectors, they will always give you an idea about what they mean by when they say reciprocal system of vectors. Because they don't expect people to know these names when they are preparing. Okay. So if you look at your JEE main syllabus, probably you will never see this word there. Correct. So how would JEE will frame this question? They will frame this question by telling you the meaning definition of reciprocal system of vectors. So let me define it for you. So let's say there is a system of vectors A, B, C. So this is one system of vector, and there is another system of vector, let's say A dash, B dash, and C dash. So these two system of vectors, so the two above system of vectors are called reciprocal systems or reciprocals of each other, systems of each other, if the following two conditions are satisfied. Number one condition that should be satisfied is the dot product of the like terms, that is A and A dash, B and B dash, and C and C dash is equal to 1. And the second property that they should satisfy is that if you take the dot product of any other, let's say I take the dot product of A and B dash, okay, or I take dot product of A and C dash, it would be 0. Similarly, B dot A dash would be 0. B dot C dash will be 0. C dot A dash would be 0. C dot B dash will be 0. So any two system of vectors which satisfy this condition will be called reciprocal system of vectors. Okay. Why it is called reciprocal system of vectors, we will understand in some time when we are trying to look into the more detail of this. Okay. You can say IJK triad is its own reciprocal. See, a system of vector is basically a vector by which you can generate all the vectors in that space. So these are three linearly independent vectors by which you can generate every vector in that particular space. So IJK is one system of vector by which you can write any vector in 3D space. Meanwhile, there can be so many other systems also. Okay, IJK is just one of the systems that we follow. Okay, it need not be the only system. It can have, there can be so many other systems. So a system of linearly, or what you are asking is what is the system of vectors? A 3-vector system which can generate all the vectors in the 3D space, that will be called a system of vectors. Okay.
Okay, sir. Okay.
Now, here, one question will arise in your mind is, if I have been given A, B, C, can I find A dash, B dash, and C dash? The answer to this is yes, we can find out, and I'm giving this as a question to you. So if let's say A, B, C are a system of non-coplanar vector, that means linearly independent vectors, okay, then prove that the reciprocal of the system, is going to be B cross C by box ABC. C cross A by box ABC and A cross B by box ABC. So what I'm claiming is that this vector, this system of vector, or you can call this to be A dash, your A dash, you can call this to be B dash and C dash. So you can say that these three vectors would basically behave as your reciprocal for this system of vector. Okay, now how do we prove this? How do we prove this? All of you please pay attention. Nothing very difficult about it. See, all of you please pay attention. I'll write down the proof here. Now, what did I discuss with you a little while ago when I was solving that D question with you? Remember, I told you that if you are known that A, B, C are non-coplanar vectors, okay, or in other words, they are linearly independent, then any vector in our space, including your reciprocal also, it can be generated by a linear combination of these vectors. And I also told you that you could also choose a linear combination of their cross products, because even their cross products would be coplanar. Do you recall this? We had done this when you were solving that D question, correct? And your A dash, B dash, C dash, which is basically acting as the reciprocal of this, they are no exceptions, correct? So A dash, B dash, C dash will also lie in the, can also be generated by the linear combination of these non-coplanar vectors. So I'm saying let my A dash, B dash, C dash be this, correct? Now, what do I know about the linear system of vectors? That if I do A dash dot A, I should get a 1, isn't it? This is a property which I've already given to you, correct? In other words, if I take the dot product with A on both the sides, this will only give me X times box ABC. Rest of the two will be 0, 0. Thereby giving me X value as 1 by box ABC, correct? Yes or no? Correct? Is this fine? Any questions here? Any questions? Any questions? Any concerns? Okay. What about Y and Z values? If I take dot product with B, that means A dash B, I will end up getting 0 plus Y times box BCA, okay, or box CAB plus 0, and this itself is 0, correct? And since A, B, C are non-coplanar vector, this cannot be 0. That means Y is 0, right? Because A, B, C are non-coplanar, so this guy cannot be 0. This cannot be 0. So only Y is 0. That means this term will vanish. Similarly, without much waste of time, I can say Z will also be 0. Similarly, Z will be 0. So what do I conclude? I conclude that my A dash vector would be X, which is 1 by box ABC times B cross C, and other terms would be 0. Other expressions would be 0. So this is your A dash, and that is what I wanted you to prove here. Okay. I'm sure you are smart enough to figure it out how B dash becomes C cross A by box ABC, and how C dash becomes A cross B by box ABC. So please figure it out in a similar way. So here is the conclusion, that if A, B, C are known to you, its reciprocal system of vectors would be given by this expression, or would be given by these three vectors, and vice versa. So if this is given, then this would be the reciprocal. So they are reciprocal of each other. They are reciprocal of each other. Is this fine? Any questions? Any concerns? Okay. Clear, Venkat? Everybody is clear?
Yes, sir.
All right. Let us look into some properties. Let us look into some properties of reciprocal system of vectors. First property is if A, B, C are non-coplanar, okay, then its reciprocal system of vectors would also be non-coplanar. This is very trivial. It doesn't require any explanation. Okay. But if you go to proving it, mathematically, this result can be better be seen by the fact that the product of the box product of a vector, a system of vectors, and its reciprocal will always be 1. So this property will come from here, that if this is not 0, then this will also be not 0. Correct? Because one of them cannot be 0. If one of them is 0, then the answer will always be 0, but it is actually 1. But wait a minute, how it is 1? Can we prove this first of all? Now, the proof for this is not very difficult. You can use the expression of A dash, B dash, C dash, which we had already figured it out. So your A dash was B cross C. Let me write it in yellow color so that you can distinguish. So I have to prove this first of all. So let's start with your LHS. So this term is actually B cross C by box ABC. This term B dash is C cross A by box ABC. And this term is A cross B by box ABC. Correct? Box ABC, box ABC, box ABC can be pulled out and will come out as box ABC by ABC cube. Box ABC cube. Okay? And within this, you'll have box B cross C, C cross A cross B. Now, a little while ago, when I was doing vector triple product, we had seen the result for this. What was the result for it? Recall in BTP, we had done this. Please turn back your pages. I think a couple of pages only you have to turn. What was this?
Box BCA.
Box ABC square. Okay. So this will give you box ABC by box ABC cube times box ABC square, which is clearly 1, as you can all see that. Okay. And hence it is proved. This itself is a very important property. And that's why they get the name of reciprocal system of vectors, because the box product of ABC is reciprocal of box product of their reciprocal system. That's why the name reciprocal system of vectors is given to them. Please do not think that A dash was 1 by A. There is no such relation like this in vectors. Okay, there is no such relation like this in vectors. Please be well informed. So this name has come because of this fact that STP of a system of vectors and its reciprocal system of vectors are reciprocals of each other. Okay, Hence the name a reciprocal system of vectors. Now this concept will not spend too much time because it is not a very hot concept as I discussed with you. But yes, we'll take some problems so that our understanding is clear with respect to this. So let's take, let's have this exam question. Find the set of reciprocal to this set. Find a set of vectors reciprocal to this set. Okay, so I mean, we need not spend too much time on this. Let's say I call this as A, B, and C. Okay, so I want a reciprocal set of vectors for this. So the reciprocal set of vectors, as we discussed, would be, let's say, A dash, B dash, and C dash. So A dash would be B cross C by box ABC. B dash will be C cross A by box ABC. Now I'm sure many of you would be like, oh, I know how to find these out, so why to waste time? Okay, absolutely fine if you don't want to solve this, but you should be just knowing about these expressions. Okay, so box ABC, you know how to find it out. Okay, box ABC, we all know from our determinants that it is nothing but the components, or you can say IJK components. Okay, so just figure it out. Oh, I'm so sorry. Yeah, B cross C, you know how to find it out. So just figure it out and divide this result and your job is done. No need to do it if you can do it. So you can just take this as a homework and proceed. Okay. So with this, we close this reciprocal system of vectors. As I told you, it is not a very, very hot concept. But yes, if at all like you get a question based on this, they will back it up with a bit of theory so that everybody knows what is the reciprocal system of vectors. And then probably they will ask you a question. So chances is that you can get a question on this in your JEE advanced exam, not in JEE main exam for sure.